Okay, so in this video I'm going to do the proof for number 3 of the limit laws. So the limit law was saying that, hey, the limit as n approaches infinity of a sub n plus b sub n is equal to the limit as n approaches infinity of a sub n plus or minus the limit as n approaches infinity of b sub n, which equals a plus or minus b. Okay, so now, from the theorem, we're assuming, so it says if a and b exists such that the limit as n approaches infinity of a sub n equals a and the limit as n approaches infinity of b sub n equals b, then all of the following limit laws apply. So here's what we're going to do. For the proof, let's be given. So first of all, we start with epsilon. We need to choose an epsilon. So let epsilon be greater than 0. Okay. Okay. Now, since we're assuming, right? We're assuming that the limits exist, right? We're assuming that we have those limits. Okay? So then what we're going to do is, since we know that the limit as n approaches infinity of a sub n equals a, right? Since that limit exists, then what that means is there exists some number, right? Some real number, n1. Or no, not real number, sorry. Positive integer. So there exists some positive integer, n1, such that what? The difference between what? A sub n and a, right? The absolute value of the difference has to be less than epsilon over 2. That has to be true, right? Now, again, I'm just choosing my epsilon arbitrarily, so I'm just saying, hey, let's get a positive epsilon. And I know if the limit exists, then there should be an n1, a positive integer n1, such that this has to be true. That's from the definition of a limit existing, right? So that's that epsilon definition. Okay, so now we also know, what do we also know? We also know that since the limit as n approaches infinity of b sub n equals b, there must exist what? A positive integer n2. Oh, hold on. I want to be complete here. I forgot. Hold on. I forgot one piece, right? So one piece of the definition. So since the limit of a sub n as n approaches infinity equals a, there exists a positive integer n1 such that this holds true for all n greater than or equal to n1. That's what I forgot. Okay, that's the. And then what I'm going to do is I'm going to say the same thing for b sub n. Since the limit as n approaches infinity of b sub n equals b, there exists a positive integer n2 such that the absolute value of b sub n minus b is also less than epsilon over 2. Okay? Now, one last thing. Let n equal the maximum of n1, n2. So what does that mean? That means now, when I add or subtract them, oh, hold on. I keep forgetting my, this is for all n greater than or equal to n2. So now it makes sense that I want to let n equal the maximum of the two, because whatever the maximum is, then I'll know that if for all n greater than that maximum value, the maximum of the two, then I know both of them will satisfy the inequality. So let n equal the max of the two positive integers n1 and n2. And so what does it mean? It means that if I take the absolute value of the difference between both of these sequences, so let's do the sum. I'll just do the sum. It's the same thing with the taking the subtraction, but I'll do the sum. Okay. Then the absolute value of a sub n plus b sub n minus a plus b. So the difference of this sum minus the difference of this sum. Well, now how are we going to make this work? This is where the triangle inequality comes to the rescue. Okay? So what I'm going to do is I'm going to rearrange this. Okay? So this is equal to, I'm going to distribute the minus sign, so I'm going to rearrange this and make this into a sub n minus a plus b sub n minus b, right? Okay, so all I did was distribute the minus sign and just rearrange things. Okay, now this is where the triangle inequality comes in, because for absolute values, the triangle inequality says that this sum is less than or equal to a sub n minus a, right? It's less than the absolute value of this piece plus the absolute value of, this, right? Okay, good. So now it all falls apart. Now it's all going to come together now. Because now this is what? This piece is less than what? It's less than alpha divided by 2, right? Hold on, got one piece here. Right. Just going to put it at the end, but. So if I let n be the maximum, then for all n greater than or equal to n, then we know this is equal to this, and then by the triangle inequality, has to be less than this. Well, we know this is going to be less than what? This, epsilon over 2, and this has to be less than also, where is it at? Epsilon over 2. Which equals epsilon. And there's the proof. Therefore, what? No, I think that's it. Do I need to say anything else? Which therefore, then the limit as n approaches infinity of a sub n plus b sub n equals a plus b. And that's the end of the proof. Have a great day.